Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of square roots, specifically how we can simplify radical expressions that involve square roots, and we'll do it in 5 minutes or less. So before we look at any of these big ones, let's just make sure we understand how square roots work. Right? So let's say I want to take this square root of 4, keep it really simple, times the square root of 9. Okay? So I could do it a few different ways, right? I could say, you know what, the square root of 4 times the square root of 9, put those together. It actually makes the square root of 36. So you can multiply those and bring it under one square root. Or you could say, you know what, the square root of 4, that actually is equivalent to 2, right? We know 2 is a perfect square. So we could say 2 square root of 9. So we can leave that 9 within that square root if we want to, and we can just leave the 2 on the outside, and that means 2 times the square root of 9. Or we can say, you know what, I know the square root of 9. That's actually 3. So 2 times 3, right? And what does 2 times 3 equal? 6, which we know is the square root of 36. So you see how square roots can be simplified. If you can find a perfect square inside of a square root, you can bring it to the outside, right? And so let's think of something that's kind of simple before we get into these big ones. So what if we were to take, or to look at the square root of 125? Okay, so when we're thinking of square root of 125, we're wanting to simplify it not necessarily to a rational or irrational number. We're not wanting to round it. We're just wanting to see is there a way to express it a little bit more simply. So what we're thinking would be what are some of the perfect squares, right? So 2 squared equals 4. Just kind of go through your squares like this. 9. We're thinking 16. 5 squared is 25. 6 squared we just learned was 36. We're probably just going to go up to 81. So let's get to 64, 81. We can go a little bit higher, but I doubt we're going to get larger than that. And what we're thinking is, you know what, how can we divide 125 by one of these numbers? And hopefully, it's just going to be a guess and check, right? But hopefully we think, you know what, let's try 125. And you know what, 125 divided by 25, that equals 5. So this is what we could do. We could split this up into square root of 25 times square root of 5, because 5 times 25 makes 125. And then we can rewrite this right here as 5. We can't do anything about the square root of 5, because that's still going to be an irrational number. But square root of 125 is going to go into be a much better expression of 5 square root of 5. So now that we've kind of got that under our belts, let's try some of these big ones. 245. And so when we're thinking 245, we should be thinking, all right, so how can we divide 245 by some of these perfect squares? And after a little bit of guessing and checking, you should hopefully see that 245 can kind of be split into the square root of 49 and the square root of 5. Okay? So what we're going to do then is we're going to leave that square root of 5 just right where it is, because we don't know what that is, but square root of 49, that's 7. So the square root of 245 is the same as 7 times the square root of 5. And if you don't believe me, do the square root of 5, multiply it by 7, write down what the approximate number is, because it's going to be irrational, and then take the square root of 245, you'll find the same thing. So let's look at 243. All right, and so if we are doing all our due diligence, we're going to find that, you know what, the closest we're going to get is that 81 right there. So 243 is the square root of 81 times the square root of 3. So then we say, all right, square root of 81 is 9. That's the perfect square I can get out of that. That's still going to leave the square root of 3, but this 9 square root of 3 is a simplified version of that square root of 243. So you're looking for a perfect square inside that you can take out.